Let's see. Mark your own. Here we go. How much work? Okay. My first thought for this was work equals force times distance. Did they give me a force? Did they give me a distance? So my brain scratched that out. I could probably figure out a force, and I could do a bunch, but It's also the area underneath a force versus distance graph. Did they give me? No, they didn't give me a graph. What's my third definition of work? This is the work energy theorem. It's the change in potential plus the change in kinetic. Now, this question here, I'm going to have to assume it's on level ground. I don't like that. On a test, I would include the phrase horizontal or on level ground or something like that. What's change in anything? This is going to be a half mv final squared minus a half mv initial squared. Oh, and you know what the final kinetic energy is going to be? Comes to a stop. So I'm going to get work equals negative 0.5 times 950 times 45 squared. Negative 0.5 times 950 times 45 squared. Do you all get negative 961? I'll call it negative 962,000. I'm going to be fussy. No negative. I would take a half mark off here because the car does have to lose energy. We are doing negative work here. Work is measured in joules. Energy is the ability to do work, which is why energy is measured in joules. What is the minimum? Oh, now I think I'm going to say cleverly, work equals work, which is weird, but I'm going to say negative 962,000, although I'm going to use my answer button, equals force times distance. Now, if you ended up with a negative force, I'll be okay with that. Technically, they're in opposite directions, and so the right-hand side, I would introduce a negative because I'd have a negative, and I would say friction is positive, but I'm not going to be that fussy. I think I'm going to get this. The force of friction equals 962,000, I'm going to use my answer button, divided by 150. The average force of friction is 6,410 newtons. What is the minimum coefficient of friction required to stop the... Ooh. Well, I guess friction equals mu times the normal force. I guess mu is going to be friction divided by the normal force. I'm going to imagine a quick free body diagram. I think it's going to be gravity down, normal force up. I think friction would be pointing that way, assuming the vehicle is moving to the right. Would there be a force pointing to the right? Does there have to be a force pointing right if we're moving forward? No. That's okay. You know what? I don't know the normal force. Oh, but look. I think I can say this. So it's going to be 6,410. I'm going to use my answer button divided by mg. It's going to be answer button divided by bracket 950 times 9.8. For us to bring this car to a stop, we need a... Yep. Okay. I think I was just about to hit equals, if I recall. Let's see. Do you get 0.689 or 0.69? Why minimum? Maybe the car had plenty of braking, skidding to spare. In fact, if this is what your tires were, you would feel like you were just about to start skidding. I don't know if how much you've driven yet, but you can kind of feel through the frame of the car, this is not good. So 0.689. One mark for each one of those, and I'll be me and I'll go all or nothing. RCMP, oh, 3 marks. Investigating an accident. The car has struck a pedestrian. There are no witnesses. Okay, So we ended up for this one saying our approach was going to start out by saying a very obvious statement, work equals work. And what we were going to do, Donald, is we were going to go force times distance equals change in potential plus change in kinetic. I think the change in potential is 0. And again, if there was a hill, you could figure out the change in potential and you would just include it in, you're still good to go. And the force was the force of friction. Okay. This is going to be mu times the normal force times distance equals a half mv final squared minus a half v initial squared. V final is 0. And technically this is negative because the force and the distance are acting in opposite directions. I'm going to start dropping my negatives now and just make everything positive, and that's one of the reasons it says speed, not velocity. We're not going to be fussy about direction here. I don't know the normal force. Although I think the free body diagram, would it not be the same as this one for a car coming to a stop? Alexis nodding. I agree with Alexis. So I think I can say in the next line, mu mg equals a half mv initial squared. Oh, that's kind of convenient. I think I'm going to get v initial equals 2 mu g. I did this last time too. I forgot to drop the d down. I caught myself this time though. D square root. I think that's right. VI is going to be the square root of 2 times 0.55 times 9.8 times 52. Square root of 2 times 0.55 times 9.8 times 52. How many of you, by the way, have a Casio kind of like this? I like that you don't even have to hit brackets in your square root button either, dude. Jeez, this is nice. Do you get 23.7 if I round up properly? I would probably give you half mark for that line. First of all, 3 out of 3 if you got it right. But I notice I basically did 6 lines of work. So, probably like that. I don't think I'd give you anything for saying work equals work, although that is the aha moment. Number 3. I like number 3. How fast? Ignore friction. Ooh, is there a change in height? Is there a change in speed? Is there a yucky curvy path? Conservation of energy. K E initial plus P E initial equals K E final plus P E final. And it looks like the only one that's 0 is going to be that one. It's going to be a half m v initial squared plus m g h initial equals a half m v final squared. I didn't need to tell you the mass of the kid. Did I tell you the mass? I did, but didn't need to apparently, at least for this part. I'm going to go times by 2, times by 2, times by 2. You don't have to. You could just divide by 0.5 square root. I like that one because it brings up my old friend of VF squared equals VI squared plus 2AD in disguise. It's kind of one of my built-in error checks. I'm probably doing this right. Square root. It's going to be the square root of, was it 8.3? 8.3 squared plus 2 times 9.8 times 21. 8.3 squared plus 2 times 9.8 times 21. You get 21.9? First of all, a bit of a built-in error check. I knew they'd be going faster. That's how water slides work. In real life, you actually lose a fair bit of your speed to impacting with the water and to friction. If you've ever gone water sliding all day on a nice day, for example, you might find at the end of the day your back's a bit sore. You've scraped your back up a little bit. It's worth it. Totally worth it, but still. 21.9. For 4 marks, 1, 2, 3, 4, 5, I'd probably go something like this. 1 mark if I saw that. I'd probably give you 1 mark if I saw that. Half mark for the... No, hang on. I got way more to play with, Mr. Dewick. Probably 1 mark if I saw that and 1 mark for the answer. Oh, something like that. Suppose they're only traveling 60... Ooh, how much energy was lost to heat? That's why I had to give you the mass. So again, it's going to be conservation of energy. KE initial plus PE initial, KE final plus PE final plus heat. I'm going to get the heat by itself. That's going to be KE initial plus PE initial minus KE final. Heat is going to be a half mv initial squared plus mgh initial minus a half m, not vi, Mr. Dewick, v final squared. Okay. Heat is going to be, what was the mass? 45. 0.5 times 45 times 8.3 squared plus 45 times 9.8 times 21? Yep. Minus 0.5 times 45 times how fast? 16 squared. Oh, wrong button. 0.5 times 45 times 8.3 squared plus 45 times 9.8 times 21 minus 0.5 times 45 times 16 squared. Let me make sure I type this in right. Looks good. 5,050? Is that right? Joules of heat. If you got that, 4 out of 4. Otherwise, I would probably do something like this. I would give you 1 mark if I saw that. I would give you 1 mark if I saw that. I would probably give you 1 mark if I saw that. Half mark for the numbers. Half mark for the answer. Something like that. Roller coaster, roller coaster. Roller coaster starts from a standstill. Oh, that's nice. What's its speed at the bottom of the hill for 2 marks? I think I can say, first of all, is there a change in height? Is there a change in speed? Is there a yucky curvy path? Definitely conservation of energy. I think I can say all of my initial potential turns into all of my final kinetic. I think I can say mgh initial equals a half mv final squared. Mass cancels. V final is going to be 2gh initial square root. It's going to be the square root of 2 times 9.8 times 90. Clear. Square root 2 times 9.8 times 90. Works out evenly, 42. Okay, I would give you probably half mark for that, half mark for that, half mark for that, and a half mark for the answers. How fast will the coaster be traveling at the top of the next hill? I'm going to use the clever trick of pretending that's the ground. So my height now, instead of 90, is 40. That's my H initial. That's going to let me still let potential energy final be 0. So I'll write out the full law of conservation of energy. But I can say, yay! You don't have to do that. It'll work if you have all 4 terms. It's just a lot more typing, but totally doable. A half mv initial squared plus mgh initial equals a half mv final squared. Mass cancels. Times by 2, times by 2, times by 2. Those cancel. And I end up with Vf squared equals Vi squared plus 2gh initial. Vf is going to be the square root of what was, Vi was 0, right? Wow, I could have canceled that out a long time ago. Well, that's a bonus. 2gh initial, that was silly of me. Square root of 2 times 9.8 times, what was h initial? 40 this time, right? When I did my modification? Yep. 2 times 9.8 times 40, square root of that. I think this will also work out evenly. 28. 3 out of 3 if you got that. Otherwise, I would probably go half mark, 2, 3, 4, 5, 6, probably something like that. Ooh, bow and arrow. How much work is being done here? I think I can go force times distance. It's going to be 130 times, nice try, Mr. Duick. 0.7. And I get 91 newtons of energy stored. 91 newtons, 91 joules of energy. How much potential energy is stored? 91 joules of potential energy. Not MGH because we didn't change the height. This is stored potential energy. If you want me to give this a name, Camille, technically elastic energy, but it's stored. If the arrow has a mass of 18 grams, nice try, Duick. 0.0186 kilograms. I think I can say all of the potential energy turned into kinetic energy. The potential energy initial becomes the kinetic energy final. 91 joules equals mv squared over 2. I think V is going to be 2 times 91 divided by 0.0186. Don't forget the square root, Mr. Duick. Do you get 98.9? Yep. Meters per second. Ooh, how much was lost to heat? I think here, my equation, by the way, for 2 marks, 2 out of 2 if you got that. Otherwise, I would probably give you half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. How much was lost to heat? So I think I'm going to say that 91 joules turned into kinetic energy plus heat. I think heat is equal to 91 minus the kinetic energy. Heat is going to be equal to 91 minus 0.5 times 0.0186 times 54 squared. 91 minus 0.5 times 0.0186 times 54 squared. Do you get 63.88, 63.9? Sorry if I go to 3 sig figs. 63.9 joules of heat. That's a bonus. That one's all or nothing. Can you give yourself a lovely score, please, out of 23?